December 4th, adding and subtracting functions. Functions are also able to be used in normal arithmetic operations. We can treat them almost like a variable. And add, subtract, multiply, divide, square, square root, absolute value, anything really. Let's see how it works. And here we define what f of x is equal to, g of x, h of x, that's how you describe these functions, j of x, and k of y. And each one has something going on. Multiply by 2, add 1, multiply by 4, subtract 5, multiply by negative 3 and then subtract 4, multiply by 2 and then add 2. If we want to add functions together, such as f of x plus g of x, what we do is we take what f of x is equal to and substitute. We take what g of x is equal to and substitute. So what we're really adding is 2x plus 1 plus 4x. Since there are two x terms, we can combine like terms, and we get 6x plus 1 as our final answer. In short, we're able to replace f of x and g of x with what the function actually is. Then, just combine like terms. Adding is simple, but subtraction can be annoying. Remember that you're subtracting the entire second function, not just one term. For another example, f of x minus h of x. So we have 2x plus 1 for f, and we're subtracting x minus 5 for h. So I'm going to put those parentheses there, because that reminds us we have to distribute the negative. And in fact, this becomes 2x plus 1 minus x plus 5, because the negative applies to the x, and the negative makes the negative 5 positive. So now when we combine like terms, 2x minus x leaves us with 1x, 1 plus 5 plus 6. X plus 6 is our final answer. One last suggestion, make sure you're keeping track of your variables. Take one last example. And j of x, up at the top here, is defined as negative 3x minus 4. And if we're going to add to this k of y, we're adding 2y plus 2. And notice I can't combine negative 3x and 2y because they are different variables. So I just leave them separate, and I can only combine the constants. Negative 4 plus 2 is a negative 2. And this is my final answer. Try these, then we'll go through them together. So on the left here, I've replaced g of x with what it's equal to, 4x, and f of x with what it's equal to. Because I'm subtracting a function, I'm going to put the parentheses around it. That way I'm reminded to distribute. So really I'm taking 4x minus 2x minus 1. 4 minus 2 is 2, and I keep the negative 1 separate because it's a number, not a variable. Here, I'm done. They're all three different terms. They can't be combined in any way. The next two, I'm adding the function j of x here on the left, and then I'm subtracting the very same function here on the right. So notice I don't need to bother with parentheses when I'm adding, but I do when I'm subtracting. So this becomes 2x minus 3, which is negative x, minus 3, as I take 1 minus 4. First thing I do over here is I distribute, so 2x plus 1 stays the same, but now it's plus 3x and plus 4. So when I combine like terms, I have 5x plus 5. Very different answers, depending on whether I'm adding or subtracting. The most common mistake is forgetting to distribute to the second term as well as the first. For the top left problem here, we have negative 2x plus 1 plus x squared. When we combine like terms, there are none. So if we wanted to, we could rewrite this in conventional order. And that's our final answer. Remember that adding a negative 2x is the exact same thing as subtracting 2x. They're no different. For f of x, that's negative 2x plus 1. And for k of x, I'm looking at plus 2x minus 1. So the 2x's cancel out, the 1's cancel out, and my final answer is 0. G of x is 7x, and h of x is x squared. So if I combine like terms, I have x squared plus 7x. M of x is negative 12x minus 12. And if I add to this L of x, that's 5x plus 4, I have a negative 7x minus 8 for my final answer. K of x is 2x minus 1. And now I'm subtracting a function, so I'm going to make sure to put this in parentheses and distribute. So 2x minus 1 stays the same, but now I'm adding 2x and I'm subtracting 1. So when I combine my x terms, 2 plus 2 gives me 4x, and when I combine my numbers, it becomes minus 2. M of x is negative 12x minus 12, and if I add to this 5x plus 4, combining my x terms, I have negative 7x minus 8. Notice these two problems are the exact same. For the very last problem, I use some colors to line up how these would be substituted. We notice here on the far right, we'll end up with plus 12x and plus 12. And this goes back to combining like terms. We start with the largest exponent, which is x to the second power, or x squared. There's only a 1. We'll cross that off because we're done with it. Then I go to my x terms. I only look at the coefficients, so I have negative 2 plus 7 is 5, plus 2 is 7, plus 5 is 12, plus 12 is 24, so plus 24x. I'm done with all of those terms. Now the constants, positive 1 minus 1 is 0, plus 4 is 4, plus 12 is 16. And that's my final answer.